The IDATA Project presents a tour of the 24-inch telescope with Tyler Linder. This video references the model of the 24-inch telescope you should have received in the mail. If you want to get oriented to this model and learn where its different parts are in an accessible way, check out the link on your screen, which is https://goo.gl/G, lowercase t, d, uppercase b. Alternatively, you can scan this QR code and it'll take you right to the YouTube video.
Alright, Penny, welcome to the 24-inch telescope. I'm glad you made it up the long journey of 40 steps in the spiral staircase to reach the dome. I just want to point out to remember that although it may be dark in the dome, we'll have 4 additional steps to go from the dome floor up to the telescope platform. The platform is actually a second floor in the middle of the dome. We can raise the floor up and down using buttons over by the telescope. You typically will raise the floor or lower the floor when doing optical observing so that you can stand comfortably while looking through the eyepiece. So now I'm going to use a remote to move the telescope. Here's a 3D model of the telescope so you can follow along with the motions. First, I'm going to push the up and down buttons. This makes the telescope move in declination. You can move the model in declination by holding the base still and only rotating the optical tube from horizon to horizon. Now I'm moving the telescope in right ascension, or RA. We move the telescope in RA by using the right and left buttons on the remote. You can move the model in right ascension by holding the optical tube in place while rotating the entire base of the telescope. You should be able to hear the Velcro of the model crinkling. If you play around with the model a bit, you'll see that the motion of the telescope is different depending on what part of the sky the telescope is pointing at. Now let's look at the back of the telescope. The back of the telescope is at the end of the optical tube where there'll be a raised bump on your model. This is what we call the instrument package. This is where all of the equipment that is used to record the light and focus the light by the telescope. Here at Yerkes, we want to be able to both look through the telescope as well as record light with a CCD camera. We do this by using a flip mirror. This device will divert the light to either the eyepiece or the CCD camera and can be controlled locally here or via a software program. It's a little bit of a mess back here, so you'll probably need to reach up through to follow along. Okay, so let's start with the bump on your model. The first instrument behind the telescope is the focuser. The focuser allows us to adjust the distance from the CCD camera to the telescope. At the beginning of the night, when the mirror is still relatively warm, the focus will be at a different position than when the mirror cools down. Behind the focuser is the flip mirror. And on the flip mirror, we have one instrument port with the camera and the second one with the eyepiece. And like I had said before, the flip mirror allows us to attach up to 4 different instruments, or eyepieces, and we can easily switch from one to the other. It is shaped somewhat like a box with 4 large holes that we call ports. We have an eyepiece in one of the ports and a camera and filter wheel at the other port. The last 2 ports are empty for now. We can choose which one we want to look through by simply pressing the button. We care most about the camera and filter wheel, so let's move around to get a better look. The 2 lighter colored boxes attached to the flip mirror are the camera and filter wheel. The larger metal box closest to the flip mirror connector houses the filter wheel. So the light path comes out of the telescope, goes through the inside of the focuser, to the flip mirror, is then diverted through the filter wheel, and finally arrives at the CCD camera. The CCD camera is what actually takes the images, and it is the final part of our optical system. It is the part of the system with the 2 handholds and all the connectors and cables. Moving around in a circle, we can again see the eyepiece. Notice how small these devices are compared to the actual telescope. The optical tube of this telescope is around 10 feet long and weighs almost 4,000 pounds. So Penny, here's your tour of the 24-inch telescope. When something goes wrong in our nightly operations, you'll have to come up here and determine what's wrong, but we can also do this remotely via the software. Do you have any questions?
Nope, I think I'm good for now.
Okay, if you need anything else, just ask.
The IDATA Project is funded by the National Science Foundation and is a collaboration between the following sponsors: Logos Consulting Group, Turk, Associated Universities Incorporated, the University of Chicago Yerkes Observatory, the University of North Carolina at Chapel Hill, and the University of Nevada at Las Vegas. People involved in making this video. Narration and script, Tyler Linder. Script, Kate Meredith. Narration, Penella Gast. Script, video editor, and audio description, Katya Gosman.